Hi, Trigoners. So we are going to look at our packet for notes today on pages 12, 13, and 14. So I'll do two separate videos, one for pages 12 and 13, and then a second video for page 14. So if you look at page 12, we're going to talk about independent and dependent events. Okay, so if you have two events, A and B, we would say that if the probability that A occurs does not affect the probability that B occurs, those events are independent. So for example, I might say, if you're rolling a die, and so if I say, okay, the probability that I roll a 2. So if I ask you, what's the probability that I roll a 3 on the second roll or something like that? Rolling a die, flipping a coin, that's independent. Okay, it doesn't matter if I rolled a 2. That does not mean that I can't next time. Okay. Okay, so what about dependent then? So if the probability that B, or excuse me, if the probability of B is dependent on the probability of A or vice versa. Okay, so let's see, if we were trying to think of something that was dependent. So for example, let's say if I have a deck of cards and I say, what's the probability that I choose a queen if I pick one card from the deck? Well, let's say that I held on to the queen, and then I said, or I held on to my card, and let's say someone else picked a card, but I didn't have a replacement or something like that. Well, wouldn't choosing another queen be dependent on whether the first person got a queen or not? Okay, so this might be kind of tricky. So what we're going to do is do a few examples. So for example, what if I said there are 24 numbered balls in a lottery and they each have equal probability of being chosen. And what if I said, okay, here's what happened. There you go. On Sunday, they chose an 11, on one day a 14, etc. So what if I said, will the number being drawn on Saturday be independent or dependent of the numbers drawn prior in the week? Well, that'd be independent. Because again, there are 24 numbered balls. You pick one at random, you throw it back in, and then you choose the next day. What if I said, what is the probability of picking a 12 3 days in a row? I think this is actually kind of an ambiguous question. What if I said, what is the probability of picking a 12 3 specific days? So, for example, the probability of Sunday, Monday, Tuesday, or the probability of Monday, Tuesday, Wednesday, or the probability of Tuesday, Wednesday, Thursday, or the probability of Wednesday, Thursday, Friday, or the probability of I'm using an hour for Thursday. There you go. Or the probability of Thursday, Friday, Saturday. So notice when we're saying or, we're adding. We're going to talk about that also. So if you think about it, I need 3 days in a row. So if I said 1 out of 24 on Sunday, 1 out of 24 on Monday, 1 out of 24 on Tuesday. So really 1 out of 24 cubed, but it's I have 1, 2, 3, 4, 5, right? 5 different chances. So 1 out of 24 cubed, if you add those together 5 times, we'll multiply by 5. So that would be the probability of any 3 days in a row of picking a 12. Let's talk about another example. What if I said C is all college students arrive to class on time. D is the roads leading to the college are icy and dangerous. So if I said to you, is that independent or dependent? Well, I would say that's dependent, because wouldn't you say that the students need to drive slowly? Because of poor conditions, right? So I think that coming to class on time definitely would be dependent on the conditions on the road. Okay, let's talk about something called mutually exclusive right now. So here are three events. The total is 11 when I roll a pair of dice. A pair is rolled, or the total is 12. So again, I roll 2 dice. What is the probability? Excuse me, the three events. The total is 11. A pair is rolled, or the total is 12. So if I say mutually exclusive, okay, that would mean that they have nothing in common. Those two events can never occur simultaneously. Okay. Mutually exclusive would be a total is 11 and a pair is rolled because there are no pairs that equal 11. So that would be mutually exclusive. They cannot occur simultaneously. So B and C are not mutually exclusive because a pair of sixes would have a sum of 12. Okay, let's go ahead and turn the page. Page 13 now. We're going to talk about cards. So let's take a look at this would be a deck of cards. What if I said to you, what is the probability if you choose a card at random that it's a face card? Well, we're calling anything with a face on it. So jacks, kings, and queens of all 4 suits. So there are 12 face cards, and there are 52 cards total. What about the next example? It says probability of a face card, then an ace of hearts. Okay, so here we're choosing 2 cards. So I specifically had to tell you we're gonna replace it. So I'm gonna choose a face card. Right, and there are 12 face cards. And notice when I say and we're going to talk about this later on too, when I say and, I'm multiplying. Okay, so if I say a face card and then the ace of hearts, well, there's only one ace of hearts. And notice, again, there are 52 cards, and I replaced the first one, so out of the 52 cards in the deck, I have a 1 out of 52 chance of choosing the ace of hearts. So you would multiply that together. And you can reduce if you want. Okay, actually I would even be fine if you left this on your paper. Okay, what about part C? It says, what's the probability of 3 and then another 3? Notice they said without replacement. So there are 4 3s in the deck. But then I didn't replace the 3. So now there are only 3 3s in the deck and only 51 cards to choose from. So again, you can multiply it out if you want. Oops, I'm sorry. Up here, that was a mistake. That was 3 out of 6, 76. Sorry. And this one was 12 out of 2, 6, 5, 2. And again, you could reduce it, or I would be fine if you just left it like this. Okay, what about part D? Part D says, what is the probability that you choose one card and it's not a face card? Well, since there are 12 face cards and there are 52 cards, there must be 40 non-face cards. So 40 out of 52. Okay, E, some people get confused for E. How come you don't have to say replacement or not a replacement? Notice for E and F, I'm only choosing one card. So I don't have to say with or without replacement. So for E, it says, what's the probability of a king or a queen? Well, you can think of it this way. There are 4 kings. Or is add, there are 4 queens. Right? So notice when I'm adding, there are 4 kings and 4, you can choose one card, 8 kings and queens. Or you could think of it for part F, red or black. Well, think about it. There are 26 red cards. And there are 26 black cards. So you have a 100% chance. Okay, the last one on this page, it says, what is the probability of a 4 of diamonds or a red card? Well, here's where it gets tricky. If I say 4 of diamonds, there's only one 4 of diamonds. And if I say or a red card, and we said when you say or, we're going to add. So or is adding, and there are 26 red cards. Here's the problem. You had an intersection because the 4 of diamonds is red. So that means you would have to subtract 1 out of 52.
get the answer.
Great job, everybody.